Hello and welcome to this FieldView webinar, Bring CFD to Life with FieldView 18. My name is Shane Wagner. I'll be your host and moderator. With me today is Yves-Marie Lefebvre, the FieldView Product Chief.
Thank you, Shane. Thank you, and welcome everyone. I'm glad you've been able to join us today. So we're going to cover all the details about this new version of FieldView, FieldView 18, which is available for download now on our customer center at fieldview.highlight.com. So here's a quick list of the new capabilities, and this is also an outline of today's presentation and demonstration. So as you can see on the right, we've focused quite a lot on having better rendering in FieldView 18 with this Bring CFD to Life topic. So I'll start with that and describe the improvements we've made to rendering. So new material rendering. This is a new capability that really has a feeling that we did more for your managers and new customers than for yourself. If you work every day with CFD, you're very familiar with your CFD flow field, the simplification of your geometry. Well, your managers and your customers, maybe they are not. And so having more realistic rendering of the different parts in the design that they know very well is going to make it easier for them to understand your results. So that's really one of the main ideas behind this new material rendering capability. So how did we do it? We've added a couple of capabilities that all together create this better rendering feature. The first one is that we've added 16 predefined materials. That's important because that means that you won't have to find the right settings, make complex adjustments. You just have to go ahead and pick one of the materials we've defined for you from one of the large thumbnails that you can see on the screen capture here. And they're great because they give you a sneak peek at the material and also an idea of the context when you will want to pick such a material. So let me show you how that works. Here I'm going to create the rim for my wheel. And once I've created the rim, I can go from the old geometry coloring to the new material coloring. From the Materials tab, you can see that I can pick any material I want. And you can see that it's immediately applied, and the performance is also great. So that's very, very interesting as well. So how did we reach that performance? We are using a technique called environment mapping. The idea is that we're using images in the lighting calculation to simulate reflection. So FieldView 18 comes with 6 of these images, 6 predefined environments that we've called default, courtyard, street, sky, sky and sea, and sky and grass. So let me show you how you can select them. So from this helicopter case, you can see that by default we are working with the environment called sky. So it gives us a nice reflection of a cloudy sky in the windows. Now if I want to use a background, I go to the background environment panel, select an image, and here I'm picking an image of a forest. So now if I pick a different environment, the one called sky and grass, you can see that we have a reflection of trees, sky, and grass that is a much better match to the background that I'm using. So the idea is really that you'll have the ability to pick an environment that works well both for your particular application and the background image that you're using with it.
Yves-Marie?
Yes?
I had a customer ask this the other day. I thought perhaps it would be valuable here. Can you add your own user-defined environment?
Yeah, that's an excellent question, Shane. So for now, we have decided to stay away from the ability to add user-defined environments. The reason is simple. To have an accurate calculation of the lighting, you need that image to be provided in a very specific format, in a very specific form. So we don't want people to just add any image to that link and have deceptive results. But we'll be adding more environments in future versions. We'll keep improving this capability. And also, if you have a very specific need right now, just contact us and we'll discuss how we can satisfy that need.
And how about the materials? I had a similar question for user-defined materials.
Well, the answer is kind of similar. So we are working with predefined materials. First, I don't think that we'll have that much need from users for defining new materials. I think most of the metals you will want are already available. Then I'll describe how you can change the color for some of the materials. So that covers already a wide spectrum. And then I want to clarify that we don't yet support any material that will require a texture. Say carbon fiber, for instance, you need to have the drawings, really the texture of the carbon fiber on the material. FieldView doesn't have yet support for that. But with 16 materials and a lot of them with editable colors, I think we're already covering a very wide base.
Okay, thanks.
All right, the next thing I want to tell you about is the new boundary types filter bar that we have on the boundary surfaces panel. So we have a new bar that you can see over here. The idea is that you can filter your list of boundary conditions based on a string or just one character if you want. And we really wanted to work on that to help you create combinations of boundary conditions and give a material to them. So that was really an important prerequisite for working with materials. Let me show you how that works. So here I'm going to add wheels to my car. So I'll type in tire first. So all the boundary conditions that have tire in their name come up. And then I can go ahead, pick material. You can see, by the way, that we also have a shortcut access to all the materials. You don't necessarily have to go to the materials tab. Next, we'll type disk, and I do select all and OK, and then all the brake disks components are selected. And finally, I'll type rim, and so the rims get selected, and I can give them a different material. So we go for something shiny like chrome. So you can see how when you have a lot of boundary conditions, you can very quickly apply materials to them by using the boundary types filter. Now, you could be working with very long lists. Maybe you don't know, but FieldView lets you work with up to 20,000 entries in that list. And we've checked it for you that the performance is going to remain great even with that number of boundary conditions. So I really think you're covered with this new capability. Let me also say that I've just demonstrated how you can just type simple characters here. It has support for more advanced wildcard matching. You can use a question mark to skip just one character, or you can use an asterisk for matching 0 or more of these characters. So it really lets you filter the list in an advanced way.
Yves-Marie, this is clearly powerful for people who have long lists of boundary names. What about the case where a user has all of the walls defined as a single boundary?
Yeah, that's a really good question, Shane, and that's something you often see, especially with solvers used in the aerospace industry. You will typically have just a single boundary condition for all your no-slip boundary conditions. So the first case will be that you have the ability to think about it at the time of the meshing and generate different surfaces for the different materials that you want to work with. If it's too late and you didn't have the chance to do that, Another trick that I've been using has been to append to your session the geometry in a different form. You may know that FieldView has an STL reader. STL is a common format used by CAD tools. So you could import the CAD geometry and append it, as I said, and it often has more details, so it also makes for better rendering. FieldView has the ability to rotate, scale, translate a data set compared to the other one, so you could also put it back into position if it doesn't really match the flow field. And then from the CAD, you will have all the details you need for applying different materials.
Okay, great. Thank you.
All right, next, colors. Materials in real life come in infinity of colors. So that will be the case as well in FieldView. Materials like plastic and glass have editable colors. Let me show you how it works. So if I have a material that can be changed in color, I just hit the color wheel and adjust the color the way I want it, hit OK, and you can see that the red car turns to blue right away. So that's really nice. It's been a long-standing request from a lot of users to have an easier way to define colors in FieldView, and also the ability to work with a large number of colors. Well, there's no limit to the number of colors that you can use in a single FieldView 18 session, so that's going to take care of that request. Let me also zoom in on that panel over here. You can see that it's really nice. People are probably familiar with this panel, as you can find it in a lot of applications. It comes with basic colors that are pre-selected, that are predefined, that you can easily select. And it also has this custom colors corner over here in the bottom left corner. It's really nice if you have colors that you're going to use all the time. What you can do is pick one of them, then adjust the color, and hit add to custom colors, and that last color is going to be added to the selection. So you have 20 colors that you can work from. If you close FieldView, reopen it, they are still going to be saved. So again, if you have colors that you work with all the time, this comes really handy. All right, so that covers the improvement that we've made for rendering. Let me move on to the next topic. So started with last version, FieldView 17, we started to provide improvements to and new capabilities regarding data analytics. You may recall that Octave is now available as part of the FieldView package. We've provided some sample scripts for doing different kinds of analysis. Well, with this version, we keep enriching this environment. We are providing additional scripts and examples. We've made further improvements to the new point query function that can also work on surfaces now in addition to volumes. And we've also made a nice improvement to how you can save your animations. In addition to AVI and MP4, you can also now save them as individual images. So in addition to it being very desirable, well, if you want to work on your animations outside of FieldView, they are great for being able to do analysis on the images. If you looked into data analytics, you may know that data often has to be resampled so that you could work with an amount of data that is manageable, and also is always at the same XYZ locations over time. Well, images can be used just for that, since your pixels could be the location at which you will make the analysis. A tool like MATLAB or Octave has a lot of nice functions for dealing with images. So that will be another way to get your data into forms that you can then analyze. So if you have interest in this topic, I want to mention to you that we have a new tutorial on data analytics. It's going to teach you how to use FieldView and Octave for doing a lot of things, but especially how to perform a fast Fourier transform, how to extract modes with singular value decomposition, and how you can visualize the mode shapes, but also a register order version of your flow field inside of FieldView, as you can see in the images over here at the bottom. It comes with a data set that applies to this. It comes with a lot of Octave example scripts, and it's a fully detailed operation. So a really nice tutorial. Let us know if you want to get access to it. All right, so in FieldView 18, we keep adding new CFD-specific capabilities. You may recall that in FieldView 17, we added a new Q-criterion native function. Well, we're adding a new one in FieldView 18 with the Lambda2 vortex detection method. Let me show you how that works. So what we'll do is go to the function specification panel. We need to create a new function. So that's where you have the Q-criterion and Lambda2 buttons. When I hit the button, then I just need to select my velocity. It can be any velocity if you want to be absolute, relative, if you want to be an average. So you define which velocity to work with. You give a name to the function. And from that point, it becomes available as a scalar function. It works really great with an user surface. So the computation could be a little bit heavy, but it's a lot faster than a user-defined formula. And then what I would recommend is that you start from large values in absolute value. So here we'll go to a better rendering and do scalar coloring on that surface. And from that high values, then you use different orders of magnitude to find the surface that is going to give a good feeling of the turbulence that you have in your flow. So I mentioned the performance. The timing that I've done show me that the native function is about 200 times faster than using formula. So that's a really good improvement. I also want to mention that this vortex detection method, which by the way has been introduced by Jong and Hussein, what they recommend is that you look at negative values. I always want to point it out because that's the opposite as Q, in which you want to look at positive values. So just remember that with this new criteria, it's all about negative values for highlighting vortices in your flow. All right, then, like with any new version of FieldView, we always try to make FieldView faster. We know that your grids keep increasing in size. We know that you always have to perform your CFD post-processing faster. So that's something that we always work on. FieldView 18 is faster than FieldView 17 in different ways. It's on Windows, it's 10 times faster to read arbitrary polyhedra, 15% speed up on Linux and Mac for the same. It's about 2 times faster doing software rendering, so it's especially interesting if you're running in batch on a cluster with no graphic card. It's faster for making animations on large unsteady cases. And finally, you're also getting much faster graphical user interface interaction on Linux. So if you have a case like I'm showing on the right side here, that is a very complex scene with heavy rendering happening. In the past, when you had a panel coming on top of it, FieldView could take a bit of time to refresh the view. It's been taken care of, and that's going to be, in terms of the ease of use, it's going to be a big improvement for our users on Linux. And for our users running on high-performance computers, we've been making further improvements. For instance, we've raised the limit on the number of blocks or grids that you can load in FieldView. It's been raised to 100,000, which is really important for especially customers in Japan using new types of methods called building cube that we see appearing in a lot of solvers over there. We've also increased the number of variables that can be supported in FieldView, raising it up to 2,000. And that's especially interesting if you're doing multi-phase, multi-species simulations. The number of variables goes up very quickly. Now, if you have needs for more high-performance capabilities, let me tell you that we've released last year a new tool called HPC FieldView, which has capabilities such as the ability to load up to 1 million grids. And we also have a version of the open source post-processor Visit that we call Visit Prime that comes with better readers and the ability to partition your plus 3D data. So that's all available now. So let us know if you're interested into that. Okay, then we've added new readers to FieldView for 2 new solvers. The first one is called UltraFluidX. It's a new GPU-based lattice Boltzmann solver from Altair. The interface is really good. It supports both serial merged files, if you have a single file, or also distributed files that can be read in parallel for the better performance, and that's really the option that I will recommend. By the way, let me thank our partners from Altair for sharing the dataset that I've been using a lot in this demonstration today. Then we've also added a new reader for a solver called SCFlow that comes from Cradle. This company is especially big in Japan, and they are the makers of SC Tetra and SC Stream, and SCFlow is their new generation of finite volume unstructured solver. And the reader right out of the box comes with support for arbitrary polyhedra, moving grids, overset grids. So excellent level of compatibility with the solver with this new reader. So on these slides, I've been listing all of the other improvements that we've made to FieldView 18. There's just far too many of them, so I could mention a lot of them. Don't even fit on a single slide. I had to use 3 slides to cover the entire list. But the good news is that the detailed list is available from that document, what's new in FieldView 18. They are obviously also fully described in our documentation. So if you want to go back at the details of the improvements and bug fixes, it's all there. So in summary, FieldView 18 comes with a lot of new capabilities around better rendering. We hope that it's going to give you greater communication, better understanding of your results from your management and your customer. We spent a lot of time making sure that these new capabilities were easy to use. We keep improving the capabilities for data analytics. We are making FieldView faster with better performance. Again, FieldView 18 is the fastest FieldView to date, and we keep adding new readers. So it's a pretty packed new version. I'm really proud of the work of our team for FieldView 18, and I hope you will enjoy it as much as we enjoyed working on it. So again, FieldView 18 is available now. You can download it today from our customer center, fieldview.ili.com. And with that, that concludes my presentation and demonstrations